In this lesson, I'll provide you with an overview of view controllers in iOS. View controller is really the most foundational object on which all iOS apps are built. So this plays the controller role in this MVC design pattern, and then controllers are responsible for synchronizing changes between the application's model and the view. Now every app's going to have at least one view controller. Most applications will have several, and if you're building a really large application, you may have dozens. A view controller also responds to actions and events. So as the user interacts with your application, various actions are going to get triggered on your view controller. iOS view controllers are all subclasses of this class called UI view controller. UI view controller is the base class on which all iOS view controllers are built. So this includes a number of out-of-the-box view controllers that Apple provides, as well as any custom view controllers that you create for your application. Generally, a view controller is responsible for managing a screen full of content, and this is certainly the case on an iPhone application. Generally, every primary application screen is managed by one UI view controller instance. Now, in the case of the iPad, a view controller may only be managing a part of the screen. Given the iPad's larger screen size, it opens up some additional user interface options that may have a view controller managing only a portion of the screen. The view controller is responsible for responding to a variety of events. So the user taps on a button or interacts with a table or adjusts a slider. Those type of user actions will typically get handled by a view controller. It also responds to a number of system notifications. Things like low memory or rotation get broadcast by the system, and then that view controller has an opportunity to react to those. So here are a few examples of different view controllers that you'd see within Apple's standard apps. So we have Safari and MapKit and the Tasks app. But in each one of these cases, we typically would have a single view controller managing that full screen of content. Apple also provides some composite type of controllers, where you have one controller that actually manages a collection of other controllers. Probably the most important of which is this one called UI Navigation Controller. I would say next to UI View Controller itself, this is probably the most frequently used controller that you have within iOS. But this is a container controller to manage a stack of UI View Controller instances. So as we tap on various rows, we can push a new view controller over the top. So in each one of these push operations, we're actually creating a new view controller and pushing it on top of the other ones. We can go back to our previous interface by using this pop view controller method, and this will pop the current view controller off and revert back to the one that is sitting right below it. Another common user interface we have are these tab bars. So this is built on top of a class called UI Tab Bar Controller. This is a container controller used to manage a collection of UI View Controller contexts. So this is really about managing multiple modes of operation. So as I tab through these various features, you're essentially locking yourself into a particular context or a particular mode of operation. So if I have the featured button highlighted, I've kind of locked myself into browsing featured applications. Or if I want to browse by categories, I can switch to the Categories tab. Or maybe I want to get out of browsing altogether and go directly to search. But with each one of these selections, I'm really locking myself into a particular mode of operation. The UI Tab Bar Controller can be used to create some fairly elaborate user interfaces. It can contain not only standard view controllers, just instances of UI View Controller, but can additionally contain navigation controllers. And we see this type of interface very commonly throughout Apple's apps. We also have another container controller called a split view controller. And this is a container controller used to present and manage master detail interfaces. The master list is often presented in what's called a UI popover controller when viewing in portrait mode. Inside that popover controller, you've got a UI view controller that's managing that list of contents. And then in the screen below it, you have another view controller managing just that interface. Both UI Split View Controller and UI Popover Controller are specific to the iPad. Now, a great new feature introduced in iOS 5 is this ability to create your own custom container controllers. This feature is particularly important on the iPad. Due to the larger screen size, it suddenly opens up a whole variety of different user interfaces that really wouldn't have been possible on the iPhone. Because of that, the container controllers that Apple provides don't always meet the needs of your application. Previously, you really had to rely on hacks to build this kind of functionality, and some of those hacks kind of skirted on some gray area of intruding on Apple's private APIs. So having this functionality fully supported is a great new feature, in my opinion. So new API support was added to UI View Controller. So you'll see things like Add Child View Controller, Remove from Parent View Controller, Transition from View Controller to View Controller. And these are all new APIs for creating your own custom container controllers. You should now have a good general overview of view controllers. View controllers play an essential role in iOS apps, and we'll spend the remainder of this chapter discussing the ins and outs of using them. For a more in-depth overview of this topic, you may want to check out a document from Apple called the View Controller Catalog for iOS. You can find this in Xcode's documentation browser or out on the iOS Dev Center.